Good afternoon, everybody. Welcome to today's Advanced Design Lunch and Learn webinar. I can see quite a few of you joined, so I'll just allow a couple of more minutes just to give everybody the chance to join, and then we shall get cracking. So before we start, can somebody just confirm in the chat box if somebody can see my screen and whether you can all hear me okay as well? Okay, thanks for confirming. So I'll just wait just to allow everybody else the chance to join. Okay, so good afternoon to those of you who have just joined. Welcome to today's Advanced Design Lunch and Learn Week. Lunch and Learn webinar. So today is the first in the series of the Advanced Design Lunch and Learn Week, where we'll be going through the BIM workflows between Advanced Design and Revit. So a little bit about me. So I am Jamil Dida, and I'm responsible for providing you guys with all the content. So that's webinars, training, demonstration. I also provide technical support as well with the products I cover. So I'm one of the applications engineers here, and I cover advanced design, idea statica, and robot structural analysis, to name a few of the Simulate products. So prior to joining Greytech, I have worked as a structural engineer in the industry for several years, and my experience ranges across a whole range of sectors. So from retail to educational to residential, just to name a few. And in those sectors, I've worked on various projects where I've designed structures in steel, concrete, timber, and masonry, and both to the Eurocodes and British standards. So here you'll have a copy of this handout, and you have direct links where you can contact me on LinkedIn, and also you can send me an email to my Greytech email address with any questions you have. So you have a copy of this handout. Please feel free to connect with me on LinkedIn, and also send me an email if you have any questions. So today's session will be recorded, and we will upload it to our Greytech Content Center. So here is where we add our webinars and all of our Greytech related content. So here you'll find access to several different types of material. So they can be tips and tricks on how best to go about a certain design scenario or modeling scenario, and some industry workflows. And also we will share with you some of the best practices. So please allow up to 10 working days for this recording to be added to our content center, where you will be able to access this on demand. So an overview of what we will be covering today. So we're going to be looking at importing and exporting models between Advanced Design and Revit. So we'll look at starting off with a model in Revit, and we will then export this through to Advanced Design, and we'll make some changes, and then we'll have a look at bringing those changes back into Revit through the Synchronization tool. And make sure you stay tuned until the end, where I will be sharing with you how to repair any errors in a model. So we'll be looking at the analytical tools to bring our models up to scratch, to make sure that our models align properly, that those nodes are intersecting, that those planes are correct. So make sure you stay tuned to the end to join me where I will show you how to use these analytical tools. So I hope you guys enjoy today's session. It's time to get started. So with Advanced Design, we have several different workflows which you can make use of. So here you'll notice that we have also got Advanced Steel as part of these workflows. So Advanced Steel, for those of you who aren't aware, is a fabrication software, fabrication application. So the first workflow is, one of the workflows is where you can make use of the Power Pack. So the Greytech Power Pack is the product which sits between Advanced Steel, Advanced Design, or Revit and Advanced Design, and it provides that platform for you to be able to connect your models and make use of those BIM workflows as smooth as possible. So the first workflow is where you can go between Advanced Design and Advanced Steel using Power Pack. The second workflow, if you have a look to the right, is more of a triangulated workflow. So that also introduces Revit into this workflow. So we have Advanced Steel, Advanced Design, and Revit. Okay, so the important thing to note here is that we can start anywhere in this process, whether that's starting with Revit or Advanced Design or Advanced Steel, and we can still make our way through that process, through that workflow, and get to where we need to be efficiently and smoothly. So workflow one is perhaps one of the most simple ones. That's between Advanced Steel and Advanced Design. So the platform, the files that we use to communicate between the two applications here is either a GTCX file or an SMLX file. Okay, so here you can make changes to your model, change some of your section steel sizes after analysis and design, and then you can push that back into Advanced Steel with those changes ready to be carried through to the fabrication. Workflow 2. Now this is the triangulated workflow which I was just talking about earlier, and that involves the workflow between Revit, Advanced Steel, and Advanced Design. Okay. So today we're going to be focusing on primarily between Advanced Design and Revit. So where I will be using a GTCX file to transfer the data between Advanced Design and Revit. Okay. So if if I get started, showing you an example which I've started with in Revit. Okay, so here I have a simple portal frame, steel portal frame structure, which has been produced in Revit. Okay, so you can see it consists of a series of columns and some purlins. So I'm going to transfer this to Advanced Design and complete this structure off by adding some purlins and also some additional bracing in the front. And then we'll also look to remove some of the bracing on the side as well, just to show you how that synchronization works in stages. We also have a set of analytical tools. Okay, so this is very important in your workflow to make sure that your model is up to scratch, doesn't have any of those errors, and that you have a model which is as perfect as possible for you to go on to the modeling analysis stage. So if we have a look at some of the details here, so detecting errors, we can detect several different types of errors. So we run the check. We can then use the following tools. So we can trim or extend elements, stretch to nodes. We can also reset analytical models as well. So you have a wealth of tools available there through our advanced GradTech Power Pack. This is available on both sides. So I'll show you the same tools in action with Advanced Design toward the end. So some of the settings include a tolerance. Okay, so you can add an allowable distance between the nodes for you to consider. Okay, and now I'm going to transfer this lovely portal frame into Advanced Design to make some changes. So through the BIM Connect tool, we can either import, export, and also synchronize models as well. So in this case, to begin with, I'm going to take model through to Advanced Design, and then I'll synchronize some changes which we make in AD. We also have the option to open it directly in Advanced Design. So I don't have to export that model and then go into Advanced Design and open it again. I can automatically launch it with Advanced Design using the direct launch application. So I'm going to generate a report here, and this will be a general report of what has been exported to Advanced Design. So we can see a series of columns, beams have been exported, and we will see now in a second when I open up Advanced Design, we will see the structure being transferred into there, where I will make some changes to this model. Okay, so we can see exactly what is importing. So it's read the GTCX file successfully. So here is the GTCX file which we mentioned earlier. So this is the common file which is used for Revit and Advanced Design to communicate with each other. So here is our portal frame. So I'm going to begin with, I'm going to show you again the the Power Pack tools. Okay, so you can see the tools are the same on both sides. Yeah, so import, export, and synchronize. So you've got that the mirrored workflow on both sides, if you like, and also the all-important analytical tools that we have on Advanced Design. So you can see we have these on the Advanced Design side as well. So you'd run the check control and pick up any errors and you correct them then using one of the following. Yeah, so auto trim or extend, projection on plane, or stretching to a common node. So to start with, I'm just going to make a couple of changes, a mixture of changes. So they're going to be a series of adding new elements in, also then making some deleting some elements. You can see on the left-hand side in the project browser, I have a series of levels. Okay, so these levels are automatically transferred from Revit. So that's depending on the levels I've set up in Revit. As you can see here, levels 0 to 4. These are the levels which have been carried through to Advanced Design to make it easier for you to manage your model and make sure your elements are in the same systems as well. So let's go ahead and copy this column over the ridge. Okay. There we are. We've instantly copied that across. And now we'll add some bracing against the wind at the front. So it's essential to have this at the front of the structure. So I'll just copy this set of bracing across to the front on both sides here. Okay. So now I've got bracing on both sides there, as you can see. At the back, we've got a set of bracing, which I'm just going to delete just to show you how that synchronization tool works in detecting any elements which have been removed. So I've deleted the ones at the back, and added some at the front. The next, I'm going to change the section sizes from the columns. So at the moment, we've got 203 by 203 by 52 UC. Sorry, I'm just going to bring that down a weight into 203, 46 UC. So I'm just going to change the size of those columns. So you can see I've isolated my columns, very easy to see on screen there. Now let's reduce the section size down a weight. So go to 203, 46 UC. Generally a very good all-round section. A lot of people like to use this section. It's not too heavy and not too bulky at the same time. It's a good all-round section. Okay, so we've brought our section across. Okay, so I'm just going to change a few other properties so that when it comes to the synchronization tool, I'll show you exactly how it detects the changes and where to find what those changes are and what they include. So I'm just going to rotate some of these columns around. So we can change 90. I'll just show you how you can see interactive out there. The orientation is changing as I type it in, so you can see just how that looks. Let's go back to 90. That's a suitable orientation. And let's turn the structure back on. Okay, now we're in a position to export these changes into Revit. So this time I'm going to export the changes through a common file. So that GTCX file is going to carry all that information through, which I can then mirror in Revit, just synchronize those changes. So I'll go ahead and save these changes. We call them Advanced Design changes. So you can see exported the GTC. It's exported some linear elements, and you can also see what else it's exporting at each stage. So the file writing has been successful. And over to Revit, where we can now synchronize these changes. So let's have a look at how the synchronization performs with these series of changes. So I'm expecting to see the changes broken down into a series of different areas here. So you can see in the legend, you've got some new items, modified items, deleted, non-change objects. So let's start with opening the GTCX file which we just created. So let's open those advanced design changes. And now we'll see on that legend on the left-hand side, which is color-coded. So we've got 10 new objects. Okay, 176 objects will be modified. So that's most of the structures have been modified. Something to do with the mapping there. So we'll have to map again on this side. 4 items, so the bracing at the back's been deleted. 3 items have been unchanged. Okay. So here you can see the central table with all the modified items. So I can filter this down in terms of new, modified, or deleted, or even unchanged. So we'll start off with the new elements. So these are the bracing which we added at the front and the purlins of that ridge. So I'm just going to show you the changes. Okay, so if I expand on the parameters, here you'll see host application value, which means host Revit was the host, so it didn't have any members there for the ridge. The GTC file value, advanced design, we added a 152 by 1816 UB section there. But let's accept all of these changes. So you can either keep, accept, or ignore the changes. Okay. So in this case, I'm going to accept the changes. Let's now move this window a little bit so we can hopefully see the changes on the side there. Okay, so we're expecting the purlins there now to appear over the top and also along with the bracing at the front. So let's apply the changes. We want to apply the changes, yes. And you can also print a synchronization report, which will show you exactly what has been synchronized. So you can save a report at each stage. So I'm going to save a report here. This allows you to keep track of the changes you've made at each stage. So you can see, if you need to, you can refer back to these reports for exactly what you have synchronized in different stages. So the good thing here is that you don't have to synchronize the model all in one go. You can synchronize it in steps in terms of what you've changed. Okay, so that makes it very easy for you to manage and also easier to manage those changes, so you don't spend unnecessary time for the synchronization, and also hopefully avoid anything you don't want to change. So you can see we've added the purlins now over the ridge here. Okay, so there's the purlin that we added, along with some bracing at the front there. And now if we take a look at the key in our synchronization operation window, it says that the new items are 0 objects. Okay, so it's applied the new items. Next, we're going to remove this the bracing. So we deleted the bracing, if you remember advanced design. I'm just going to filter this down to deleted items. Okay, so we have 4 elements there which are going to be deleted. So simply accept. And let's apply those changes. So we'll just save another synchronization report, and you can see there's a previous one. Okay, so we're expecting to these, yeah, you can see those, the bracing now has been deleted. So you can see just how easy that process was. Okay, so it's a very powerful tool that we've got with the Power Pack here, where we can seamlessly synchronize, manage our changes with the models, get them both your structural models and your models you've created in Revit to communicate with each other efficiently and seamlessly. So if we have a look at some of the modified items here, okay, so I'll show you 2 examples. Let's have a look at some of the columns. We've got some beams and columns here, so let's narrow that down just to the columns. So you can narrow this down to the exact change that you want to see on the screen there. So now we're seeing just the change of the columns. So A, we changed the section size for all of the columns. So you can see on the right-hand side where we have the change attributes. So the host application value, there's a 52 UC, and the DTC file, advanced design, it's been changed to 46. So that's one change. If now I take a look further down, I should see some changes related to the geometry and the tone. Okay, so the geometry being the orientation of those columns, and the type being the section size. So if I expand on this, just so you can see, okay, so you can see what we have for the geometry, okay, geometry, and also the type. So you can see there where the points for the X, Y, and Z have changed. So you can see for point Z, we're now seeing the value change to 0, which was 22 before, and we've also got the type for the section size. Okay. So 22 and 0 is the new file value. It's very easy for you to narrow down those changes, control what you change and when you change it as well. You can narrow this down to geometry and type as well. So you'll also notice that the synchronization is the same on both sides, on Revit and Advanced Design. So I'm just going to accept some of these changes and click Apply. Okay, so in this case, I would need to map my elements. So I need to load the section size. I'm going to go ahead and load a family. Okay, so if it detects any unknown types, it will prompt you to load any elements. Okay, so we can load it from the library. I'll load some the UC sections in here. It's a very clever mapping system as well for just to pick up any unknown items. So let's go ahead and open that the British Standard Library for UC sections here. Okay, so let's just I'll select both of these just in case. Okay, so if you have any questions as we're going along, feel free to drop these questions in the question box or the chat box, and I will pick these up towards the end. If there are any questions which are a little bit more involved, take a little bit more time, please feel free to drop me an email, and I will get back to you with a reply to those questions. So while we're waiting, see if we have any questions. 1 second. Okay, apologies. It seemed to have skipped back to the skip forward. Okay, so I'm just going to load this family into the project. I'll also take you through some of the settings for the tolerances as well once we've had a look at this. So you can set tolerances on both sides. You can set tolerances in Advanced Design, and also in Revit. So you get to tell it exactly what those allowable tolerances are for it to run the check control to pick up any errors. So if anything's outside of those limits, you then have a chance to rectify those issues using the structural repair tools, the analytical tools that we have on both sides there. Okay, so let's look at some of the changes here. Right, so we've made some changes to the columns with the geometry. Okay, so you can generate a model just to see how those columns have changed direction. You can see that they've changed direction, so they're orientated 90 degrees to what they were originally. And now I'll just finish off with, I will modify all the columns in general. So I'm going to type in type, and just remove that, and you can see now I've got all the columns. I'm going to synchronize all of the columns now. So before I had just synchronized a few of the changes there for a few of the columns. So you can see you can synchronize a few items or all of them. Now I'm going to just synchronize the remaining columns, and then I will look to add an additional bay on the front of this structure, and then use the synchronization on the advanced design side to bring those changes through. Okay, so if I now synchronized there, you can see the orientation has changed for those columns. Okay. So let's apply all these changes. Okay. So that's how the synchronization works there for the Revit side. Hopefully you've got a better idea of in the excellent system that we have there into synchronizing models, managing those changes. So now what I'm going to do is add an additional bay to the front here, and then we'll do the same on advanced design. So we'll synchronize these changes there. So we'll just add an additional bay for the front. There we are. Okay, and let's now export this so we can mirror those changes on advanced design. So to export this as GTCX, here you can choose your type of format. You can also launch automatically. I've already got it open, so I'm just going to export the changes as a GTCX. So let's save this file as Revit changes. And the good thing is you can save files at each step. Okay, so you can go back to any change. If you've accidentally synchronized some items or you've made some changes, you want to go back to the original, you can then reload the previous GTCX file which you've saved and synchronize those changes. So that's then bringing it back to its former state. Okay, so let's go over to Advanced Design and now synchronize these changes. So you can see the system is the same on both sides here. So very easy to get to grips with. And let's load this GTX file. So you can see here that's modified. Okay, so number of projects, modified number of objects, and some new objects in there. So in this case, I'm interested in the new items. Okay. So here we have a series of beams and columns for the additional bay at the front there. So I'll just expand some of the changes in here. Let's accept all of these changes and apply them to our model. So this should be a very quick change here. You see, it's instantly added that additional bay at the front. Okay, there we go. So you can see just how easy, that smooth that workflow is on both sides between Advanced Design and Revit as well. So if I go back into Synchronization, I'll show you now some of the various settings that we have. Let's open the file again. Now I'll show you some of the settings up at the top here. Okay, so we've got some settings for the analysis. Okay, so here you get to choose forces you want to import. Okay, you can clear all the changes in there. Column options, you get to choose how you want to populate that table. Okay, so at the moment I've got several different columns. So it's down to me not only to manage the changes, and I can also choose what is the information I see on the screen there. Okay, and also I get to choose the tolerance, so the allowance, if you like. Okay. So we've had a look at now importing, exporting, synchronizing between the models. Now I'm going to show you how, in a certain scenario, when we have some models which are not quite correct, which need to be fine-tuned to iron out some of those issues in the model, where things aren't quite intersecting out of plane. So in this case, I'm loading in an SMLX file. The other option is to import a file. So in this case, I've imported a file in Advanced Design, and it's prompted me to assign material. Okay, so it's picked up the material as an S235. And this was originally an Advanced Steel file. Okay, so an SMLX file coming from Advanced Steel. So now I'm just going to load this model. Okay, and now we want to assign this C section just for this section, or we can create a new cross section if we needed to for any unknown sections. Okay, then you can export those, of course. So we're going to assign this section size. Okay, so here's our steel structure. So it consists of a series of platforms, steel platforms. And here, if I switch to axis mode, you'll see this will help us see the errors or things which aren't quite connecting a little bit better. So if I go to the Utilities tool, where I showed you the control commands at the beginning, if I run this check control, okay, this will simply run an analysis on that model, and it will pick up any errors or bad connections between elements. So here we have a series of different things that need to be fixed within this model. The question where to start. So we have elements which aren't quite connecting. We have elements which are out of plane. We have elements where there are several nodes, and we need to define one common node for everything to connect to. So you can see this model has got a mixture of errors in which we need to fix to bring this model up to scratch for structural analysis. This is a very common situation that we face as structural engineers. Sometimes models aren't quite perfectly aligned. If they're not aligned, then well, how are we going to create the mesh on our structure? How are we going to transfer those forces? We need to tell it what those intersection points are and where those common planes lie. Okay, so I'll just measure this distance here, okay, just to see what that is. But you can measure the distance for those offsets, and in the application settings, you can then specify the minimal distance according to that. So at the moment, we've got 0.04, which is more than 0.03. So hopefully, it should pick that up with the auto command. So I'll just run the control check again because I came out of that to show you the application settings. Okay, so now it's got a circle on both ends. Yeah, so we need to connect these the side beams into the primary beams along the X-plane. Okay, so I'll select all the beams here, and then I simply just choose to auto trim and extend. There we go. Just within a few clicks, and you can see it's intersected automatically with the perpendicular beam there. And I'll run the control again just to make sure, and we're not going to see any errors there. Okay, so that side is now up to scratch. Let's have a look at some of the other errors now. So there's a scenario of a member not intersecting with something which it needs to connect to. I'll just bring the tolerance down now. Just make that net a little bit finer to pick up some more errors. Okay, so on the side here, we have some cross bracing. It's triangulated bracing. If I switch to a side view, you'll see that this is actually out of plane, and it's not even connected to the columns and the beams on the side. So I'll just zoom in here. Hopefully you can see the offset there. Zoom in, and you can see that the tip of that bracing should be intersecting the beam, which is running over the top on the y-axis. Okay. There we are. You can see it's out of plane there. So what I'm going to do is I'm going to select this bracing and then use the projection on plane tool to then bring that in line with the beam which we are connecting this to. Okay, so there we are. And if I wanted to, I could measure the distance that's off by in this case if I needed to. So I'm going to select both sets of bracing, one at the top. And now let's project that on the plane. Oops, sorry, it seems like I've selected auto trim and extend there. Select again, so you have to be very careful what you're selecting. So I've selected the braces, and now select the projection on plane option. Project on the plane. And all I have to do now is describe the plane. So I'm telling it what that plane is. So I've selected the primary column and beam, and then you can see it's now snapped the bracing to the main beam there. And everything is in line for those two levels. And I've got something at the top still, so I can do the same for the top bracing. Select the other side too, and we simply project on the plane, select our column and the beam, and away we go. And you can see just how easy it was for me to A, find those errors, pick up those errors in that model, and then B, rectify those errors very easily. And now this final example I'm going to show you is an example of a series of multiple nodes. We have one intersection points, but unfortunately we have several nodes. So it's bamboozled as to what that common node is. Okay, so we need to be able to tell it what that common node is, just to make sure that those members connect at that point. So we can see we have several nodes there. So we've got the stretch to node option, which I can use to stretch I can use to stretch all the items manually onto the center point there. Okay. So I'm stretching them manually here, and then I'll show you doing these one by one how to stretch your items, multiple items, to that one point. And hopefully you can see that the error has now disappeared. So that was stretching to the node individually for each element. So now I'll just go back a few steps just to undo this change. Okay, and then run there we go. Let's run an intersection for those members as a whole. So let's stretch the node for all of those members there. So let's tell it the elements. We've selected our elements, and then we click on the central node. Very simple case, and it will automatically now connect to that point, and you can see just how easy that was. And now let's run the control command again just to see, and that connection is now perfect. Okay, so that's the end of the analytical tools there, and the end of the advanced design demonstration for the BIM workflow between Revit and Advanced Design. So now, do we have any questions? I'll just leave you guys a couple of minutes. If you have any questions related to what we've just seen, please feel free to drop these in the chat pane or in the questions box, and I'll hopefully go through these before I then close the session. So I'll just give you guys a couple of minutes to post these questions. Okay, so I can see that there aren't any questions at this time, but if you have any questions, please post them to my email address, which is once again jamil.dida@greytech.com, and I've included my email address in the chat box there as well. Okay. So before we go away, I'd just like to remind you of what else we have coming up during the week. So as part of our Lunch and Learn week, tomorrow we will be going through advanced design as a whole. So we'll be going through an overview of advanced design of what we have end to end. Okay, so that's advanced design modeling, analysis, steel design, concrete design. So we have a very brief overview of everything that we have on offer. So that's a full sketch for any structural engineer, a must, in my opinion, from head to toe. And then we also have on Wednesday, we will be going through some construction stages. So construction stages, a structural engineer's design formula. So we'll be looking through, going through some managing those changes for the construction stages. So you have a copy of this handout, and if you haven't registered for any, if you want more details of each of these webinars, feel free directly to go to our website, www.greytech.com/events, where you'll find details of a breakdown of what is included in each webinar. So thank you for now. Thank you for joining me today on today's Advanced Design Lunch and Learn webinar. I hope you've enjoyed today and you've taken away quite a bit of information on advanced design. And please follow us on social media. So that's on Twitter, Facebook, LinkedIn, and also YouTube, where we have the latest tips and tricks, software tutorials, and the latest going on in Greytech with news and offers and our upcoming events. So make sure you follow that. So bye for now, and I look forward to seeing everybody for tomorrow's session. Bye now.